Hello, everyone. My name is Sergey Aksionov, and I represent Sberbank of Russia. Hope everyone knows that company. Everybody loves it. Okay. And the topic of my today's speech is specific feature of legal applications of NLP algorithms. So it was announced as when it was announced, the title of my presentation contains the question why the processing of legal documents is so complicated task. But finally, I've decided to not to put this question into the title, but still. Okay. So I have to say that the things I will talk about today are mostly connected with Russian legal system and with Russian language, but and most of them will be connected with banking sector. But I hope that most of the things and most ideas I will express today will be also relevant in other fields, and they will be also relevant for other languages and for other legal systems. So I hope everybody will understand me. Okay. So, oh, sorry, some problem with that. Oh, 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 okay. Okay, so let's say some words about banks. What do banks do? Banks accept deposits from the public, from the people. They save their money and maybe invest this money in one way or another. They create credits and they provide payment services and make investments and they help some companies and people to make transactions and so on. But one of the main things that every bank do is create credits. It means that banks issues some money to a person or to a company, and okay, I think about it. In all of these tasks, uh, so the analysis of legal documents is an integral part of all of these tasks. So it's an integral part uh, of activity of any bank, of the work of any bank, and maybe in other companies too. And so processing of legal text is an essential part of the work, and huge because most of this processing is done manually nowadays, and a huge number of lawyers, huge number of employees are included in this process, and so it takes a long time to process one complex of documents, and automation of this process will help banks and will help their clients to live more beautiful life. Uh, and the main fact is that most of the document processing work is related to the issuance of loans, because there are so many documents that are need to be checked, and bank has to check all the documents to decide whether he may or may not to give a loan to some company or some person. So loans are different. So now we'll say some words about loans. Loans are different. They differ by amount of money, the duration. They may be long term or short term, and they differs by borrower. There are two main types of the loan. It may be a personal loan for an individual, for just a person, or a business loan for the company. And so there are or are not some loan guarantees, some loan securities, and so on. But personal loan and business loan is the main aspect we will consider. So personal loan is just some money that banks gives to a person this task is quite well studied. There are many scoring models that were developed, and some person just go to the bank, just fill some questionnaire, and his credit history is added to this data, and a scoring model can estimate the credit risks. For example, it may be the probability of default or something like that. But so it's all about personal loans. But the situation with business loan is dramatically more complicated, unfortunately. So the process of application for a business loan is shown on the slide, on the screen. So it looks like a company representative, it may be CEO or other person, applies for a business loan. The application includes all necessary documents about the company, about its financial life, and about its organization. And bank analyzes the documents and makes a decision on granting a loan or not. So you can see that this process, the algorithm of this decision, on making this decision, includes the processing of a huge amount of documents. So it may be some articles of association of the company, some protocols, and so on. And the bank needs to extract many information about a lot of information from the documents, and this process is very complicated to automate. So it's long process, and it takes actually from 7 to 14 days to process one application for a business loan. So just for one company, it takes from 7 to 14 days of manual work. And automation of this portion is a very important problem for any bank and for any company, I think, I suppose. Why automation is so complicated? So it's complicated because the legal knowledge is, on the one hand, it's very precise. So all information is contained in the documents. It does not rely on some context outside the document. All information is absolutely accurate, and there's no ambiguity in formulations. Even it may look like there is some ambiguity. Actually, there is not. But the variety of formulations and lack of templates for writing the documents makes our life harder and harder. One word can change the meaning entirely. So there's two examples I like very much. CEO may take a loan with the consent of the board of directors, and CEO may not take a loan without the consent of the board of directors. Actually, it's the same, no? These two statements have the same meaning, but it might be quite difficult to catch this meaning automatically. And this is just two examples, and that's why it may be difficult. So the approach we would like to represent here, and the approach we use in our work, is an information structure, is extraction of information from legal documents, from legal texts. So we made a suggestion that all the information we need to make a decision is contained in some facts, in some set of facts that are or are not written in the document. And So the task is to extract that fact and to analyze them, not the entire text of the document. So it looks like named entity recognition or something like that. No? So uh, there are different approaches to extract such information from the documents. And there are some rule-based system, for example, I don't know, IBCompreno or something like that, so that parse the document entirely and extract whatever you need from that. Sometimes it works pretty good, sometimes not, unfortunately. Uh, or the other approach we want to use is, but the first approach has an obvious disadvantage, is that it's quite difficult to write such amount of rules for any type of documents, for any task, for any information we need to extract. And as far as I know, IBCompreno was developed for 10 years or something like that. So the other approach we need to suggest I'm going to tell about is extracting facts as named entities, or just extracting facts using machine learning. There are also some rule-based algorithms or rule-based approaches for extracting some entities, but it's much better there. It's much better to use machine learning methods, machine learning techniques for that. There are a branch of classical machine learning methods and a branch of some approaches to feature engineering for that task, and some deep learning methods. That appears quite recently. And so named entity recognition, I think everyone knows about it. So named entity recognition is the task of detecting named entities in the text. There are few common entity types, persons, locations, organizations, and so on, that are being extracted practically in all work connected to that. And there are many standard corpora that contains other entity types, and it's quite easy to, when you build your own model, it's quite easy to estimate it, and it's quite easy to train it on that corpora. But in other tasks, the situation is much more complicated, because there is no there's no corpora, there's no any corpora for legal documents in Russian language. Of course, there are many sources of such documents, but they are not marked. It's impossible to build a supervised algorithm on them. So, and to mark them is a very, very hard task. So these problems are shown here. So it takes a lot of manual work to mark the appropriate data for training such model. Okay. And it also takes a lot of work and a lot of time to build an ontology to extract all the facts. So to start an extraction, to start solving the extraction task, we need to define all of our entities we are going to extract, and so we call it ontology. I'm not sure it's commonly used terminology. So some examples of entities are there. CEO is appointed. So CEO it's a position. I mean a position of a person in a company. I mean, some recognized group of people who make some decisions or so on. So it's board of directors, for example, and the most interesting is a competence. This the most interesting among these examples. So is as as you can see, the competence is the phrase is entitled to take a loan. Имеет право брать кредит по-русски. So is entitled to take a loan is an entity. We have to extract from the text and to make a decision based on them. So to solve our task, we had to make our own data set, because as I have already said, there is no MARC data set in the nature, in the world, for Russian language, for legal documents. And so once we created an ontology of entities, then we create detailed structure from assessors. We had 60 assessors who marked the documents for the training set, for the training data. And finally, we have got 15,000 marked documents and we use them as a training data. So features we used. So then, once we got this training set, we solved the standard, it's quite standard, named entity recognition task based on them, and we used many features there. There were some standard word embeddings, word2vec, fast text, so Glove we used. So we tried to we used pre-trained models. We used trained models. We used pre-trained models, and then trained them on some corpora of legal documents. We used our own documents. We used some open sources like Consultant Plus. It's quite famous. It's quite famous service for lawyers. There are many texts. There are many written texts in Russian. So we used, despite them, we used morphological features, post-tagging, post-text, syntactic features, some surface features, some capitalization templates like that. The first or the second letter is capital, or all letters in the word are capital. So we used also some manually created and manually designed features. I call it text-based features here. It's something like there is a word director in the same paragraph, or something like that. So actually, unfortunately, it relies. Okay, then methods. We use different methods to solve this task, and we use, for some tasks we use even rule-based approach, some rule-based techniques, context-free grammars, and so on. But for most of our entities, unfortunately, they were too complicated to extract them just by some rules. And we used machine learning methods. We used some classical methods. On that feature spec that I have shown, we trained logistic regression, random forest, and some combination of them. And we used CRF, conditional random field, and we used the famous pipeline represented by Mahovy, CNN plus BLSTM plus CRF, or the same pipeline without CNN, but with two BLSTM. The first BLSTM for charts and the second BLSTM for tokens. And then we also tries to replace the token vector space in that pipelines. We used Word2Vec, we used some symbol models, fast text, n-gram models, and so on. And so actually the best one is the last. Char BLSTM plus BLSTM plus CRF is was the best model that allows us as we think to solve this task. So the business result of all the project is that in practically in all scenario, the duration of document processing has reduced from several days, from 7 to 14, to just a few minutes, maybe 7 minutes. So we call that project 7 minutes, from 7 days to 7 minutes. And so we are proud that the process of issuing a business loan in our bank has become almost as fast as for individuals. Okay, actually that's all what I was going to say today.
Thank you very much.
Questions?
What are the goals of processing of the documents?
Sorry?
What are the main goals of the documents processing? What do you want to find there?
We want to find some information. So the example of information is that if there is a company that wants to get a loan from the bank, and there is a CEO, for example, who represents that company, and he goes to the bank and he shows the documents, and there is an information in that documents that regulates the entire life of the company, that the CEO is allowed to take a loan for 2 years, not more than 2 years, and for $1 million, not more than $1 million. And he's trying to take a loan for 2 years, or for 3 years, or for $2 million. And actually, the bank has to decline this, has to reject this issue. Even the financial parameters of the company are okay. So, and the task is to find that information in the document. So there are plenty of text where is all the information. There's all information about the company. For example, there's a amount of shares, the address of the headquarters, and so on and so on. And the task is to extract the information that whether the CEO of that company is allowed to take such a loan or not.
And if you use some approximation methods and neural networks and etc., you will have some error rate, some mistake rate. Is it plausible? Is it okay?
Yes. Yes. It's okay. It's okay to. So the goal was to maximize the recall, not the precision. So if there is such restrictions, for example, for the example I've already said, we must find it. But if there is no, but we found something, it's all right. It's all right. So false positive is much better than false negative.
Thank you.
Yeah, thank you for the great talk. Actually, I have several questions, and one of them is maybe some extension of the previous one. So you said that earlier you processed the documents for 7 days or 14 days, and then you managed to do it in several minutes. So the gap is really huge, and it seems that it is not the only thing that gave the opportunity to do that.
Sorry?
Identity recognition is the only tool which managed you to decrease the size, the amount of time required to process. Or there are plenty of steps, and you were speaking only about one of that.
Yes, yes, it's a good question. Yeah, there are a lot of steps actually. There are some compliance projects, some scoring projects that allows to automate the process of estimation the company, of estimation that the probability that it's the company is connected with money laundering or something like that. The bank has to check it. Actually, yes, there are plenty of steps, and not only natural language processing allows gives us the opportunity to reduce the gap. But the main, but in general, it's not a lie. The processing of the documents takes a very long of time because it's there was for each issue there was some lawyer, a human who read all the documents of the company, so it's crazy. It was crazy. And
just a couple of technical questions. When you detect named entities, it's actually a sequence labeling task, and you have to provide some encoding like below, below, or something like that.
mm-hmm.
So which one did you use?
Oh, we used many of them, of course. We used many of them. I'm not sure. So if I say one of them, I will lie with the high probability.
Another question is that when you use classical machine learning like XGBoost, SVM, it's a cool idea to add some historical features. So when you are analyzing token E, to add labels about tokens E-1, E-2, and something.
So yes, of course, we were yes, the feature space contains the word to the embedding for the last -1 and for the next also, and for the next and for the next +1 tokens also. Okay.
More questions?
Yeah, thank you for your presentation. I have one question. What's the real use case of your system? You make a decision, your ML system make a decision itself, give law or not, or you just highlighting some sentences to the lawyers and lawyers think about it and make
No. The truth is in the middle. There is a decision support system. I've decided not to tell about it today in my presentation because it takes quite a lot of time to explain what is it. Actually, it's a rule-based system that analyzes the facts extracted by our system. Okay, there's some facts, some set of facts that were extracted from documents, and there is a rule-based system that just analyzes it and then outputs some result.
the system is also
Yes.
And what's the precision and recall of this system against a really open error? Is it same?
No, actually, so it's the same because in any actually yes, it's the same because in any ambiguous situation this rule-based system outputs the documents to the manual processing. So there still are some lawyer that but instead of 10 there's one lawyer who helped the system in some unusual cases.
On how much cases your system makes the same decision as the manual lawyer? How much?
Uh, if we had such statistics, it was more than 95. So I don't know actually how it's being tested on the production, and I don't know how the real statistics is. The tests haven't been stopped yet, but on the dataset we had, it was 97 or something like that.
Okay, I have a question about features. The first question is how you have combined more-to-web features with some categorical ones. I mean, probably you haven't just concatenated everything. You did some.
No, for classical methods, you mean, or?
My understanding is you have generated like lots of features.
Yeah, yes.
Animation. So after that, how you have combined them and produced the final vector?
No, we just concatenated them. Just no.
I see. The second question is, have you analyzed feature importance? I'm just curious what was.
Of course, there was some feature filters, and we analyzed feature importances. Unfortunately, the most important features was, like I have said, something like the Boolean feature, whether there is the word director in that paragraph or not. And there were plenty of such features, and actually many of them were relevant. I said unfortunately because it means that we need to see on the text, we need to watch it, and we need to analyze it manually, just to make up, just to figure out the features, because it's impossible to do it by brute force, just to.
Okay, the final question is, what was your baseline model?
For that task, we
Simple baseline and then compare models with.
so I see if I understand your question. The baseline was, as far as I remember, it was something like word to vec with morphological and post-taggings and so on, and it was the feature. It was features, and then it was logistic regression, as far as I know, or CRF, or just CRF without LSTM in front of it. Yes, there was just logistic regression and CRF, two models.
And how the best model improved the baseline score?
Sorry?
How the best model, how much the best model improved your baseline score?
Oh, so it depends on how to measure the quality, but the number that I know, that I remember, is that it was about 70% F1 measure for the baseline model, and the best model has about 89, as far as I remember. 89%. Oh? Yes. Huh?
I just repeated you from 70 to 89 of something. Correct?
From 70 to 89%.
Of something. Some measure.
F1 measure, I said. F1 measure. Okay.
I'm just curious what measurable results you get. Okay.
Okay.
More questions? how we can tell?
We need to. So there are some entities that we have designed, and any of them, any of that entity may have some the wide variety of formulations, and we need any we need to find to catch any of that formulations, any instance of that entity. So, for example, we need to, or the third one is entitled to take a loan. We need to catch all the synonyms of that phrase. The goal was such. Sorry? Yes, for that type of documents, yes. But there were some another type of documents, there were some entities there. It's only for articles of association. There were some protocols for documents of changes to article, but in general it was maybe 70.
Okay, and how did you measure the code for such? Where did you take ground truth?
Take ground truths. We had a marked documents. We have marked documents.
So all the segments were already marked.
All this, I don't know where it is. 15,000. All of them were marked. Yes.
So, any questions?
How have you labeled documents? We used some crowdsourcing platform for that?
No, we had our own assessors, 60 assessors. What?
So Sberbank has its own assessors and its own
Labyrinth platform? Yes, yes. We have developed our own Labyrinth platform for markup tasks. You know, it sounds like Yandex Toloka, but much simpler, much more simple.
So it was not hand raised for question. I think we can thank speaker.